So let's do the first type of problem that we do in sequences, which is to find the general terms of sequences. So let's write the general term of each of these sequences. First, sequence of positive odd numbers. So positive odd numbers are 1, 3, 5, 7, etc. That's not a general term, that's just a list of some of the first positive odd numbers. So how do we do this? The way we would write this is we saw that we can generate the positive even numbers with 2n. That gave us 2, 4, 6, 8, etc. And if you notice, these numbers are just one less than the even numbers that would be generated by 2n. So we can write this as 2n minus 1. So that's the term. I'm going to leave some extra space because technically I always have to say what index I'm going to begin at. So this is for n greater than or equal to 1. And you will see that this actually does work, because if I let n equal 1, then that gives me 2 times 1 minus 1, which is 1. If I let n equal 2, that gives me 2 times 2 minus 1, which is 3. N equals 3. That gives me 2 times 3 minus 1, which is 5, etc. So this is a good rule for the sequence of positive odd numbers. All right, let's do the next one. The sequence negative 1, 1, negative 1, 1, negative 1, 1, etc. In other words, we just alternate back and forth between negative 1 and positive 1. So here's how we would do that. This is sort of the standard way to do that. If you think about it, if I use this term, negative 1 to the n, let's think about what that does. Negative 1 to the 1 is negative 1. Negative 1 squared is positive 1. Negative 1 cubed is equal to negative 1 times negative 1 squared. That's going to be just negative 1 times 1, which is negative 1. Hopefully you get the idea that this expression, negative 1 raised to the nth power, is going to be negative 1 if n is odd, and is going to be positive 1 if n is even. So this is a good definition of that sequence. And, oh, but I also have to say where it begins. I'm going to say it begins at 1 again. Note that if I started it at 0, negative 1 to the 0 is positive 1. So if let's just suppose that instead I wanted the sequence 1, negative 1, or 1, negative 1, 1, negative 1, etc., I could use the exact same definition and simply start it at n equals 0. As you play around with this, you'll start to see that there are other ways you could do that. For example, I could start it at n equals 1, but then make the exponent n plus 1, or I could keep the exponent as n and start it at n equals 2, but that's a little bit awkward. You don't usually start sequences at 2, even though you can. So there are a number of different ways that you could define a sequence like this, but this is a very important concept, which is that negative 1 to the n makes an expression alternate between positive and negative 1. So let's go to the next one. How about 3, 5, 3, 5? So unfortunately, there's nothing as clean as negative 1 to the n that switches back and forth between 3 and 5 like there is between negative 1 and 1. But we can kind of use it, because if you notice, this is going to be 3 is equal to 4 minus 1. 5 is equal to 4 plus 1. So it's kind of convenient, because what we can do is we can define this sequence as 4 plus negative 1 to the n for n greater than or equal to 1, because as you can see, what we're doing is we're just either subtracting 1 or adding 1 to the number 4, and that gives us either 3 or 5. So that's how you would make something like that alternate. Here's for problem number 4, we have 6, 2, 6, 2, 6, 2, and we notice is that this is going to equal, let's see, 6. We can see that we're not separated by 2 anymore, we're separated by 4. So what you want to do is kind of pick the number in the middle, which is 4, same as last time, and then we want to go either up by 2, or we can say that 2 is equal to 4 minus 2. So we're going to take 4 and either add 2 or subtract 2 to get either add 2 or subtract 2 to get either 6 or 2. So I would write this expression as it's going to be 4. Let's see, it's going to be 4 plus 2 times negative 1 to the n. And by the way, you don't want to write it as negative 2 to the n. That has a totally different meaning here because we're not raising 2 to the nth power. If I were to, let's say, if I were to, let's say, get rid of this 2 and instead just write 2 in there, then this would be negative 2, 4, negative 8, 16. That's not what I want. What I want instead is 2 times negative 1 to the n. And notice that the first thing I want to do is I want to add, I want it to be 2 times positive 1. So if I were to start with n equals 1, instead I would be getting negative 1 to the 1, which is negative 1. So it's going to be more convenient in this case to start at n equals 0, because negative 1 to the 0 is positive 1. Now how about this sequence? Anyone recognize this? If you want to stop the recording and see if you recognize this sequence. This is actually n factorial for n greater than or equal to 0. This is something you should just recognize because it's a very, very important concept in calculus. It's kind of strange because this is a very integer-like concept that you know probably from probability theory. And if you took any probability as part of an algebra course, you would have encountered factorials. So recall that let's say that 3 factorial is equal to 3 times 2 times 1, and n factorial is equal to n times n minus 1 times n minus 2, dot, 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 all the way down to 2 and 1. So in other words, we simply start with n and just keep multiplying by the descending integers until we get down to 1. And then there's an important concept, which is that 0 factorial is equal to 1. You can think of that as just sort of a definition to take care of what 0 factorial is. If you think about the probability and counting definition of factorial, it gives the number of permutations. If I have, let's say, if I have n different chairs and I want to know how many different ways I can order the chairs, it's n factorial. So if you think about it, why would 0 factorial be equal to 1? Well, if I have 0 chairs, how many different orders can I put 0 chairs in? The answer is 1 order, the order in which I have no chair. That's, it sounds sort of silly, but that's true. It's like the total number of ways that you can order no chairs is 1 way. So that's why 0 factorial is defined to be 1. So anyway, this is the sequence of that. It's if I write 1 factorial is just equal to 1, 2 factorial equals 2 times 1, 3 factorial is 3 times 2 times 1, which is 6. This is 2. 4 factorial is 4 times 3 times 2 times 1, which, by the way, note that it's just 4 times 3 factorial. So 4 times 6 is 24, and we can keep going like that. So this is the sequence of this is the factorial sequence.